get out of the studio mode. Check 1 2 3 1 2 3. We are live. We go. I'm gonna turn the volume of the music down a little bit. Okie doke. I think we're good. Yes, I think so. Ooh, people. Hey folks, how's it going? Can you hear and see me well? Everything good? Let's do that. Whoa, that is cursed. Why is it so thin? Huh. Okay, yeah, seems to be working fine. Alright, whatever. That's that. Let's see if the stream is up also on the YouTube side. Looks to be fine there. A little bit of a delay. Cool. Just gonna drop a link on Twitter saying we are live. And that will be it. Cancel this, cancel that, quote tweet. We are go. We are live. Building a programming language. Building this, not a. Okay. There we go. Okie doke. So where were we? Let's roll back into that. So in the last few streams, we've been responding to this wish I had earlier this year, right? Of having a language that's sort of, a chimera of parts of other languages that I really like OCaml, Erlang, Racket, Rust, and whatnot, right? And we started maybe 2 streams ago, trying to play around a little bit with what tooling are we going to use, what tools are we going to use to build this language, right? And also what this language is going to start looking like or feeling like, right? And there's quite a bit of things here to consider from how do you make some of these bits and pieces work together. Like, for example, having the ability to build the kind of tooling that you could build in Faro or Smalltalk, right? How does that fit in a language that is expected to have the kind of type safety that OCaml has, right? Or the kind of macro capabilities that you can see in Racket. So this language is sort of all over the place. We don't really have a problem that we're trying to solve with it, right? We're just saying these are things that we would like to have in the language, right? How can we make them make sense together? And in some way, this language is rather powerful, right? So I figured, why not call it Q, right? The Q continuum. Oh, I can't really type now. From Star Trek, right? You may recognize this guy, John Delancey. Maybe not. This is a very small picture. Yeah. He's part of this sort of race, right? that has immeasurable power. They can do all sorts of things like bend time, space, laws of physics, just snap their fingers and something happens, right? Which is pretty amazing. And as a Trekkie myself, I figured, all right, I'll just go ahead and call it Q. So we started a repo. It's a QLang. I'll actually drop this link on the stream, so you can play around with that. And we decided to go with a Rust project. So you can see there's cargo here, right? Right now we're going for something super bare bones. So we just only have like, you know, a tiny lecture that is being built with the logos library, right? I think we even have, yeah, these are the same tabs we had open last time. I've kept them around. And logos is this beautiful library for just very quickly, right, creating lectures out of a data structure. Make this a little bigger. There you go. So you sort of specify what are the tokens that you would like to have, and you can use actual constant strings to match on, like keywords. You can also use regular expressions, right? And you map those directly into sort of symbolic values, right? Like different things in an enum. You actually can capture things with regexes and just put them in there as well. So if you wanted to have something that has a value inside, which we'll see in a second, actually, might as well just show you right now. Like we have here an ID, right? Is anything that matches this regular expression, right? So if we get something that gets in there, matches that, then we will get a token. And the actual ID itself that we captured will be inside, represented as a Rust string, right? Yeah. So the whole point of the lecture, if you're not that familiar with this whole process, is that we will grab a bunch of text, right? So, for example, we have a program that we've been trying to parse here, right? And you will turn this into a series of values, right? You will turn it into structured data, really, that you can then process in some way. So right now, when we read this thing, right, we actually get out something that looks a little bit like this, right? Hello, and then equal, and then string q lang, right? So this program, this little bit of text, right, gets turned into a series of tokens that are just Rust data that we can then operate on. So that will be like the first step of what we were working on. That was the first stream. And then we moved on to actually starting a little bit of a parser. We did write some tests in the process, right, that allow us to say very quickly whether we are or not supporting the things we need to support. So this would allow us to play around with the syntax very quickly and say, oh, we're missing this kind of token, right? Or we broke a particular token. It's no longer being matched in the way we expected, right? But so far, this doesn't really help us build a language, other than just listing the things that you could write in whatever order, right? So the tests that we've written actually are kind of nice and make sense. Like here's a list with two elements, right? Here's a single floating point number that actually this is just a string, right? But yeah, here we have like a function definition, right? But when you look at the tokens that we produce, they have no meaning like at all. This is just an ID, hello world, and then there's an equals, and then there's a bunch of parentheses and braces, right? There's no meaning embedded in these tokens yet. It's something that we have to imbue them with, and the process of doing that, it's a process of parsing. So we started a parser on the second stream, where given a lecture, right, we will actually given a file or a string, we will start consuming these tokens, right, in a certain order. And in that order, we will find meaning, right? It's an interesting, I don't know, that sounded cool. In order, you'll find meaning. Anyways, so that's what we did. We also have a couple of tests here, right? Like, for example, we are parsing a declaration that's missing equals, right? We have this declaration here, and this should be an equals instead of a question mark, right? making this a little bigger. And then we expect some diagnostics, some errors, something to happen, right? Like, oh, we expected an symbol. What did we expect? An equals. Instead, we found some error, and we found an error because we don't know to tokenize this character, right? So if we added a token for a question mark, then this will become like, for example, question mark, right? And so on. So let's review the captain's log. What did we do here? We began our parser. We built an executable. We actually played around with diagnostics and ways of showing them out. We explored a parse trait. One thing we tried here was that instead of doing your like run-of-the-mill recursive descent module or struct, right, a parser, where you have all of the different functions that take care of parsing the entire sort of stream of tokens into an abstract syntax tree. Instead of doing that in the same place, we just define a trait that allows different parts of the syntax tree to declare or define independently, right, how they will come to exist, right, based on a lecture. So in this case, just to give an example, right, let's just do it here. Nope. What is this stuff? No, this is my buffer. So we have a module called parse3, right? So you can see here, and it defines a structure for an identifier. This identifier, right, implements the parse trait, and from there it takes a lecture, right, and it either returns a valid identifier or some parse error. So what we do here is we sort of try to consume something from the lecture, saying lecture.next, right? And if we get an ID token, then we're saying, all right, this is the valid ID, right? We could do more checks here. We could check that, for example, the ID wasn't empty or that it didn't have specific characters that we don't want to actually support, for example, right? And of course, if we don't find an ID, so everything else, we'll just say, well, screw it, this is not the symbol that we were expecting. We were expecting an ID. This is just an example ID, right? Some ID. But instead we found this other thing, right? That is definitely not an ID. So in this way, right, we could pull this out and just have a tiny like ID module, right, that deals with IDs in general. And we created a struct for this, right, because we don't really know what the ID is going to look like. In the future, maybe we go from a single thing to like an actual vector of strings that form a path. And now I'm maybe looking ahead a little bit, just from remembering, right? You know, Camel, you have this difference between identifiers and long identifiers, right? And they're actually both structured internally. So you can sort of describe with a data structure a path from like a module, right, to a function, like inside of it, f. Yes, so through this process, we wrote a couple of implementations for this trait, and it's, I don't know, I don't like it. I feel like maybe it will become more useful as our AST grows. But then again, I'm so used to having the AST defined up front in a single file, right, where I can just look at the data and then not have to think about how I'm actually putting that data together with some other ways, right? So this maybe is coupling the AST to the parser in some way. So we did that, right? And we wrote some notes for what to do today. I think these were the notes. Trying to ensure that all expressions get the diagnostics in even when we are out of a file. Right. And by out of file, I mean we've reached end of file, right? And then what is the distinction between parsing errors and diagnostics? And I think we wanted at the beginning to make a distinction between these two things so that we can sort of collect diagnostics nicely as you go along. So you could say, well, we've gone through this entire file module, like Q module, right? We found some things that are wrong, right, that need to be fixed. But then we just continued parsing things, right? So that's where we ended last time, and I guess we'll continue from there. We have a pretty crude top level parsing loop, right? For whatever we started with, we'll just iterate trying to read items, right? If we actually find an item, then we'll just push it into the item list. If we're out of a file, we'll break, right? And there's a bug hidden here that I'll show you in a second. If we find a diagnostic, then we actually just push that into the diagnostics, right? And then if we find any other kind of error, right, we just immediately return that error. So short circuit the entire thing. I'm gonna turn my watch into silence. How does one do that? Theater mode. Perfect. Cool. Yeah, so at the end of the parsing, you end up with a module. The module has a name. Right now, it's just coming from whatever you told us the module was when you sort of created the parser to begin with, right? Like from here, from string. I'm guessing that... Bro, we got a message deleted by a moderator. Do we have moderators? No, the Nightbot. Cool. All right. Yes, so I guess the first thing we'll do is figure out how to get the bug fixed, which is about this. Okay, let me show you the bug, right? Enough babbling. Here's the bug. When you do cargo run, we're going to run the executable, and the executable is pretty tiny. Doesn't do much, right? It just takes a number of arguments, skips the first one. Hello, hater. Hater M.A. Bood. M.A. Bood. Sorry, I'm probably butchering that username. Have you checked LuxLang? I guess, sorry about that. Yeah, okay. I'll have to figure out how to let people share some links every now and then. Let's look it up. LuxLang. The Lux programming language. Cool. New programming language in the making. Functional, statically typed Lisp that will run on several platforms such as the JVM. Damn. Beta stage. So it's got the closure syntax. Cool. Threads, atomic references, FRP. Actor model as well. Jesus, very, very ambitious. Tons of stuff. Yeah, I think this will be a very nice source of inspiration. I also think that maybe this should be added. I used to keep a list of alt flags. Is it that? Awesome alt flags, yes. Should probably put it here somewhere. Yes. Then we don't forget. Cool. I will have a look. Thanks. There's also a YouTube talk. Cool. YouTube LuxLang. Lisp. Let's see if we can find that. We will bookmark or just leave it open. Damn, this is slow. Yeah, this is not working out very well. LuxLang. 2017. Oh, is it the Strange Loop one? Nice. Cool. We'll definitely have a look. I think it's always interesting to look at other languages. One of the reasons I started the awesome alt langs is, first of all, I didn't know they were called ESO or ESO langs, like esoteric. I felt like they were alt as an alternative, right? Um, and second of all, is because I do like just having a look at some of the languages that people are building out there and trying to understand why would you do that, right? Of course I understand why, having tried to build, for example, bringing a camel to the Erlang VM before with caramel, but like, what are you actually poking at, right? That's what I mean. So looking at all these people doing amazing things with their languages is super inspiring. Cool. Right. So that's open. That's there. Closing. We'll leave this here. Yes. So back to back to Q. Essentially, the binary, right, is just grabbing the arguments and then skips the first one, which is usually like the path to the binary, right? And then just calls the parser. And then after parsing, we don't really care about the module right now that comes out of that. We would if we were trying to do something more with it, right? But right now, it's just like, okay, run it, and we check if there's any diagnostics, and we're doing a pretty like a sort of K person debugging. Like, all right, whatever, I'll just debug all of the diagnostics one by one, if there is anything. So if there are no arguments, then nothing happens. But the moment you say, okay, I'm gonna debug something, then you get an error if there is an error somewhere. So this is the program we're passing it in, right? Main queue. If I turn this into a question mark, right, then you'll run it, and you would expect to see some error out, right? But what happens is that, actually, this one did work. Fun. How was it that it didn't work? Right. If I forget, for example, the right-hand side of this definition, right, when I run the program, nothing happens, right? It's completely fine. Like, no errors whatsoever. If I do have enough to actually finish parsing a single module item, then I will get a bunch of errors. So in this case, you see that it says, unexpected symbol found, and this is not meant for users to see. It's just for debugging purposes. We expected an equal. Instead, we found an error. So let's actually make that a little nicer. We're gonna go into tokens. Wait, I'm gonna declare bankruptcy in Vim. Just close everything. So we're gonna say, all right, we want a question mark, right? A question mark. So now the error should actually say found a question mark instead of this other thing. Okay, so I think I did save a change that I shouldn't have saved, maybe? Yes, in parse tree. There you go. Save that. Build again. These are all the changes. Perfect. Cool. So yeah, unexpected symbol found. Expected question mark instead found. Expected equal instead found the question mark, right? I'm not looking for like a pre-existing language. I just want to build something. Otherwise, I would have eventually settled for some of the amazing things in that list. I think carp actually is in that outline list. Nope, no, that's not the one. Yeah, carp's here. Okay, so What's the problem? The problem is that as soon as we run out of content, right? So we have an equals here, right? Then we are ending without actually lifting, right, a diagnostic saying something is wrong. Because we don't actually want this to be an okay file. We want something saying, hey, we expected an expression here, but instead we found nothing, right? So why is this happening? Because if we go into a parser, I'm actually going to close the bottom one. There you go. When we go into a parser, eventually, right, the module item parser, which is going to be defining the parse tree, right? Just going to walk myself through this. Tries to actually parse value declaration, right? Because that's one of the things we can do in a module right now. Maybe we'll have more later on. And inside there, we're saying, all right, value declarations have the shape. You have an ID, right? You have an equals, and then you actually have an expression. So we're going through this one just fine. We're going through this one just fine, right? We're expecting that. But then afterwards, when we're trying to parse an expression, we are failing, right? We are coming back saying, hey, there actually isn't enough of a file, and we break. So at this point, when we do break, right, and we can double check that by saying hello, oops. Yes, out of a file. At this point, we would actually like to be able to say, well, we are, we're not really done parsing. Like, file ended abruptly. We expected an expression, instead found nothing, right? So we want to be able to handle that. And I think that goes against what I was trying to do in the beginning of the stream, on the last one, right? Where we said, let's wrap the lecture, the Logos lecture, into a lecture of our own that we can use to handle things like running out of tokens. So when we do run out of tokens, we immediately say we're done, right? There's nothing else to be done here. Unfortunately, this does not have enough information right now, right? There's not enough information for you to be able to say, I am not done. I'm expecting something more. So I think this will happen with any, I think it would happen with any kind of sort of sub or smaller parser that we're trying to write here. Hello, Regina Eva. How's it going? All good? And the whole point of having Next do that would be to not have to deal with, this case, the non case. But it appears that we will have to do that. So we would have to say, well, if you have some token that is not an ID, that's fine, right? We didn't expect that, so we should tell you that that's that. But if you have no token whatsoever, then there will be a different kind of error that says, hey, I was actually expecting this token, but instead the file ended abruptly. Now that I say that, though, it sounds like something we could maybe pass in, right? Like you're saying, Lexer, give me the next token, but you may also say, right, if there's none, then what do I expect, right? Expected for a second, right? Let's assume that this makes sense. You will call next and say, all right, give me the next token on end of file, right? Or actually, yeah, I guess on end of file. Then you will want to be able to run something that returns a diagnostic, right? For how to report this back to the user. Maybe that grants looking back at the diagnostics. Because right now we only have these two, and they're actually maybe even redundant, right? Like expected expression could be unexpected symbol found, expected this thing, found the other one. So what will we do here? Let's assume that we do have this. Go back to the expression here. it would say expression from lecture. If I go to the expression struct, there will be a parse implementation, and in here we will call next, right? So let's say we do have on the end of file. What do we do? Got any ideas? So the easiest thing I could think of is just to say, all right, you get to pass in a diagnostic in here. So it's up to you to build it, right? Like you would build a diagnostic, right? So you know exactly what's going to happen, or actually maybe even just some action option. So if there is something for you to complain about when the file ends, right, and there's no tokens, then you can say so. Oh yeah, I'm not in love with this. I think it will be okay. It is the extra bit that we're looking for, right? To say, hey, the file has ended. There is nothing more to be parsed, but right, it's not very elegant. Maybe it'll do for now. Okay. Actually, I think what would be better even is to just say, okay, if you have no more tokens, right, and there is a diagnostic, right, then we will just return that diagnostic. If there's no more tokens and you have no diagnostics, right, for this, that must mean that this is okay. It's okay for you to finish sort of the partially parses, which will mean we just return end of file. Else, if there is some token, then it doesn't really matter what you're passing in there. It should be fine either way. Cool. And I guess the first place to use something like this would be the expected or the expect combinator. Not really a combinator, I guess, but the thing that lets us say, hey, Lexer, I am expecting this token. So they like grab the next token that we have in the stream and check that it is exactly what we are expecting. Because if it's not, then we'll just, return a diagnostic, an error saying, yeah, this is not what I was expecting. I think something we wanted to do last time was to collapse this as well, so the unexpected symbol just becomes a parse error, right? Instead of having this additional layer of a diagnostic in the middle. But let's do one thing at a time. Okay, so if you're expecting a token and the token does not exist, right? Then we would have an unexpected end of file, I guess. So we can say some diagnostic unexpected end of file. And then we can say expected. So we're just passing the token that we were expecting. Whoa. Oh, sorry. Missing a parents there. Cool. So let's go back here, and then slowly this is gonna grow into something. We'll just move to the parser. Unexpected end of file. and then we'll have expected token. Yeah. Compile. It's probably gonna fail. Perfect. Okay. Maybe we should split this into two functions though. Something specific to just say, well, I'm gonna get the next character, right? The next token, and I expect it to be there. And if it's not there, then I will fail somehow, right? With some diagnostic, and then another one that is like next, but if you're done, then whatever, right? It's fine. Let's see. So we're trying to parse an expression, right? And here we would say unexpected end of file. Actually, when would it be okay for you to be like next and then there's no file? Would it ever be okay? Don't actually think so. Because if you're still executing the parser, you're still trying to get something more. You kind of always want to be able to say, hey, the thing I wanted is not there. But maybe instead of pushing this into the lecture, that's something that each one of the individual parse implementations need to decide, right? You're saying next and you expect the thing to be there. If something is not there, but you can live with that, like for example, let's say here, module item, right? The module item might say, well, we're gonna try to parse something, but if there's nothing there, then we're good, right? A module item being one of these things. In this case, like a value declaration. However, at this level, right, if you were to get an end of file, right, then it would not be okay. It would be very uncool because you're clearly in the middle of something. Whereas this one is more, I guess I will evolve to be more of a dispatcher, right? And yeah, I don't know. There's other ways that we could structure this as well. How's the sound, by the way? Is the music too loud or something? Just want to make sure that I'm not unheard. Unheard? Or that it's hard to hear me. Dope. Amazing. Okay, so parser. If we remove this, right, then I think if we undo some of these changes, so we just return an end of file, and it's an error because it's what we expect, right? Oops. What else did I miss? So parse tree. There you go. No, that's good. Run. Perfect. Okay. So that would mean because the file is finished, but we're not done quite done parsing, we get an error saying we reached the end of the file, right? And that is an error in this case. So if we went back a little bit just to make sure things are good, if we run that, eventually we will always reach the end of file, right? Eventually the module item will say, hey, are we done? Because we're sort of in the loop doing that. And this goes back to something that we hadn't done before, which is, can we pick on the lecture to say, is there anything else for us to parse at all, right? Or not? And one of the problems we had with logos was that it didn't quite let us do that. So in lore, when I was building lore, right, I actually had to build in the parser a wrapper, and this wrapper became sort of the source for the QLang lecture, right? Where we wrap the logos lecture and say, well, we are going to also store somewhere in here in this data structure the next token, so that if you pick at that token, we show it to you, but we also save it as the next token that will be used, right? We don't want to lose that. We just want to let you say, hey, this is the current token, right? If you call next, you will get this thing, right? And then it will be sort of consumed. So this is what I built before. We're going to build something similar, right? We just have an optional token, and I forget why we have an option of an option. But let's see. So we got a peak mutable. When you call peak, we check. If there is nothing peaked, yeah, this seems unnecessary to have a double option there. Because calling self lecture next, right? That calls the next function inside of the lecture that comes from logos, and that already is an option, right? So in our code here, right, you can see lecture next returns some. Okay, so we want to do something like self. Actually, we need the mutable there. Either we get a token or we don't get anything, right? When we do that, yeah, that sounds about right. So assuming that we have a place, what did we call it before? Peak token. We'll actually say peaked is going to be none. We haven't picked anything, right? When you try to pick a token, if we don't have a pick token, then we want to pick a token and save it, and then we show that to you, right? I guess we will have to figure out how to deal with the parser, because we will have to call next here. Maybe not self.next, but maybe lecture.next. Okay, let's do. If we don't have a token, then we want to get a token. Else, we are actually going to just return you a reference to that. So self.picked. Right? That looks about right. If we don't have one, now we actually can get you one. And we would do self.lecture.next. I think that should be okay. Probably want to write some tests for this. Can peak, I guess. Shows the next token. So if we have a lecture, and actually we don't even need a lecture, we just create a lecture from source, and we pass in some source like 1, 2, 3, 4, right? We get a couple of things there. Then we should be able, actually let's do just 2. Then we should be able to say lex.peak, right? And this should be some token, and I think it's gonna be float. Alright, I'm just gonna use an equal here. I expect this to fail, and we can do that twice, and that's fine. But once we call next, right, and then we actually get that token, if we call pick again, then we should get something else. So yeah, this is a terrible set of assertions, but let's see what happens. All right, use super. Give me everything that super has. Cannot compare. Pick. Right. I guess I need to dereference you. And you will be unwrapped. We need to unwrap this one because when we call next here, we actually get a result. Okay, that looks about right. Cargo test peak. Let's see what happens. Perfect. We got an error because we don't know how to parse the number one. Great. Token here. We'll do number, right? And we'll just do a U there. And this will be any number. Could be very big. Okay, cool. This is probably not a good enough regex for a number right now. I mean, generally speaking, I'm just removing the dot from the from floats, but it might be enough for us to pass or get a different thing there, and it's not. Why? Oh, well, actually, I'm just gonna do plus there. There we go. That's the stuff. Still failing. I'm gonna start closing a couple of things. So when we pick a character, right, token, then we get the number 1, which is great. Now we expect to pick it again, right, and get the same number. So I expect the assertion to be exactly the same. It failed, right, but the line will be 55 instead of 54. So there you go. Run 55. Cool. So same thing here. We can do 1. Now, if we run that, then we will also fail. What? This is not what we wanted, right? When we were picking, we got number 1. Now that we do next, we actually want to get number 1 first because we haven't really consumed that character, right? That token. So here we actually expect number 1. But what we got instead was number 2. Clearly, when we called self lexer next, right, that consumed the token. And this will mean that when we call next here, then we actually have to check. Have we picked something? If we have, right, then we return that, right, instead of calling self lexer next. How did we do this before? I think I implemented iterator on pickable lexer. So when we called next on the pickable lexer, right, we took the lexer, the picked value, and returned that if we had one. But if we didn't have one, then we actually called next. Okay, so that seems reasonable. So that's sort of what we want to do here as well, right? So if self.picked is none, then that's fine. We want to do this thing. Else, we actually want to do self.picked take, and this will be our okay. But I do think that this maybe will be wrong because we have an option. So maybe instead of doing that, we can just do some, right? And do picked. And we will just return okay, picked. And then if we don't have a picked value, then we can actually try to match on the lexer after calling it and say yeah, yes or no. Now maybe I'm getting ahead of myself a little bit. Pick still not being used anywhere. Just want to make sure that it does the thing that we expect it to do, right? Line 61. So this actually worked. So if I do 0, 0, 0, or actually 99 there, then I expect the error to be 99 versus 1. Perfect. All right, so assertions again, we pick 1 and we pick again and it's still 1, and then we do next and then it's still 1 because we haven't yet consumed this first token, right? So that worked. Good job, everyone. And after that, if we pick, we actually get the number 2. So I would expect the error to be equal versus number 2. So I think that will say that this pick is working as expected. Number 2. Now the question would be, if we do call next again, right? We get number 2. Actually, what do we get here? I'm going to just do a random number. And if we call it next again, then I expect this to be a token. I actually expect this to be an error. So error, and then this will be token, parser. End of file. Am I missing a brace? Maybe I can just do one wrapper. Unwrap, error. There you go. Cool. What's the problem? Implementation of partial equality is missing for that. All right. Error. Let's go for that. And we'll do partial. No, partial. Okay, equality. Yeah, this is not going to fly. Cool, great, amazing. I don't think I won't be able to implement partial EQ for standard I/O because I don't own that, right? But what we can do is error and check that actually assert is true. Cool. So after we pick number 2, if we try to next it, then we get it. And then the next thing that we should get here, if we do a pick, should be none. There's nothing. Oh my god, that worked. Should it have worked? Just want to see the test failing beforehand. Cool, yeah, that makes sense. So after that, after you pick and you say none, or if you try to call next, then that will be none as well. And if you keep picking, then there's still nothing. All right, cool. I am convinced that this sort of works as expected, give or take. What do you folks think? Any thoughts? I want to get some Coke in the meantime. Coca-Cola. Not sponsored or whatever. I'm just really fond of this stuff. My dad used to make my brother and I work a lot on stuff. Building things, actually with our hands, you know, that sort of thing. And then by the end of a day of work, on a Saturday or a Sunday or something, he would bring like almost frosted bottle of Coke. And it just made the whole day feel like worth it in some way, right? But now that I don't have to go through that, I can just order Coca-Cola. It still tastes just as good. Get a ping somewhere. I'm going to mute that. Just enough with the notifications. Application, who are you? Settings. No sounds, please. Thank you. Mute all. For 8 hours, I think it's fine. Cool. We're not going to be streaming 8 hours, though. Just setting expectations here. All right. Let's get back into it. So why do we need peak? Why do we even want peak? We want to peak because we want to be able to say, I want to loop as long as I can pick the next character, right? As long as there's something else for me to parse, a token, right? I will want to try to parse something. So instead of doing a loop here, what we're going to do is just say while, right? While, can we do while let, maybe? While there is a token to peek, right? So lecture peek. Yeah, I guess that's just as good, since we're not really using the value. While there is something to peek, we're gonna go ahead and pick it, right? And at some point, we're gonna run out of things to pick, and then that will be the end of that. But that means we would be able to actually distinguish, right, an end of file error, because we could not, we found that an end of file token before we expected it, from an actual file being done, like an actual stream of tokens being consumed completely. So that's something that I think is better than what we had before. Probably very likely can still be improved. Let's have a test, right? We're gonna do run, and it didn't fail. It just went straight through, and that should be fine, right? Because we have Q line here, everything's fine. But if we remove the actual definition to the right, we would expect this to be a failure, to be an error, right? There you go. We reach the end of the file, right? And so on. It's not the error we want right now, but that's okay. And I think that's okay because we still haven't done the work of handling, right, the right errors, or rather, bubbling up the right error. Right now, we're just saying in the file, right, automatically because of this little question mark here, right? Perhaps what we want to do instead is just say, okay, if you are okay with this, then that's fine, right? If you do give us a token. If you do have an error, right, that will be parse error in the file, then we can return a different error. We can rewrite this to be specifically about parsing expressions. But actually, we don't really know at this level what the problem is. It's more likely that one level above here, we know, we have more context about what is happening. So if we go one level up, right, we go into the expression from lecture line here. Here we can actually say, oh, we were trying to parse a value declaration, but instead we found this other crap, right? And the file. So let's use a better error there. So here we can do map error, right? And there's still something I'm iffy about. I don't really like that. I don't really like this question mark thingy happening. Not that I don't like the operator. I think it's great. I wish we had that operator in all the languages like ReScript, right? I think it will make a lot of code so much nice to work with. Even if it's just for result and option. Even if it's just for that, right? At the end of the day, it does work as a bind operator for those two types. Okay, whatever. So we have a map error. We're going to ignore that error for now, right? And we're just immediately going to return something more specific. And since we still have diagnostics, then I will just use the diagnostic here. And the diagnostic here would be diagnostic. Unexpected in a file, I guess expected expression will be fine. We don't really have a token though. I wonder if we have expected expression anywhere else. Yes, we have it here. Okay, no. So we're gonna do something else. Missing value in value declaration. And we're gonna go here and put that right there. Cool. I think we can remove this one. Save, compile build, we should expect to see missing value in value declaration as an error. Boom. There we go. So this will allow us to build, right? Very nice error messages for these specific cases. So if we had like nothing here, right? Empty module. Actually, this wouldn't be a good example. Never mind. And it wouldn't, because the parser will just say, hey, peek, there's nothing. All right, bye. Right? And then just return a module that has no items. Cool. Works. If we have an error on the line below or above, right? Then we should expect some error there. Missing value in value declaration, right? And then it says unexpected symbol found. Why are we doing that? Okay, but one thing at a time. I think that we solved that bug, right? So now if you have an error at the end of the module, then you actually will see that error instead of before where you didn't see it, right? We obviously don't have enough information yet about where exactly this is happening. So at some point we will do that. We will extend our lecture, maybe our tokens, to include more information about this, right? The exact line and column, so we can say, oh, right here. Actually, the whole point of using Miet, in case you missed that, right, was to be able to just give an error like this, right? Say, oh, that's what's happening. So maybe we can commit this stuff, just say, okay, we did one change, right? We actually fixed something there. Ooh. And let's actually get a date here. So first of all, we wanted to fix bug where last or maybe be able to distinguish between a good file ending and an interrupted, I don't know what the phrase is, an interrupting or an interrupted parser due to an in the file. I think that's what we did, right? By being able to peek into the lecture. Cool. So that'll be the first thing. And the second thing that we would like to do today is just to look a little bit into this, right? The distinction between parsing errors and diagnostics. I think just want to get rid of diagnostic right now and just say, okay, everything will be a parse error. We may want, actually we already have a mechanism for collecting parse errors as we go along. So that's fine. That'll be the first thing, getting rid of that, like collapsing the diagnostic type with the parse error type. And I would like after that to also skip ahead on a parse error. So the thing we were looking at here, where we have this file, right? And we would expect this thing to be a parse error, right? This whole thing. But this thing to be properly parsed, right? That's something that's bugging me, and I would like to be able to say, all right, we know that we're parsing a value declaration. We got an error, right? Let's actually just skip to the sort of final character we're looking for. And continue parsing from there. So we can say, okay, this is an error, but this is fine. I don't expect this to always be possible, or to always be easy to do, or even to always work well, even if it was possible and doable or easy. Because for example here we know that this value declaration, right, has a name, an equals, and then an expression. If we were to say, okay, I'm gonna skip until the end of this my expectation here, right? That would say maybe find the next expression, or maybe we just have to say skip until, right, the next value declaration, which would be the name. I don't know. I think we'll have to play around with this a little bit. In any case, we have something to commit. We have a little bit of tests. Let's see if we broke anything else. We did. Huh. What did we break? We broke stuff in the parser. In the parser. What's this? Line 93. Diagnostics. Oh, okay. I think there's no more error. Now there should be a question mark. Perfect. Question mark. And if I run that again, everything works. Nice. Cheers. Okay, so add everything, and this will be a feature, right? Distinguish in a file, or yeah, I guess what did we write here? Distinguish between good and file. Yeah. Pushed. Yes. Again, we're actually doing this in a public repo, right? It's called QLine here. If you scroll through the chat, you'll find it. Yes. There's not much more right now, just the little source code that we're writing. Yes. It's here. I'll drop the link again. If you want to play around with that. Yes. Okay, so next thing, getting rid of the diagnostics. So diagnostic, this will be straightforward. I'm just going to grab this stuff. I'm going to go into error, right? I'm going to drop the stuff right here. So there's one thing that we need to do here, and in this case is that because we're using the Miet diagnostic trait, we'll have to implement some of these things, right, for them. But that should be fine. This is never constructed. We can get rid of that. We will get rid of this, right? And now I think we will want to have a nice string for this. Yeah, I don't yet know how this scales, right? It may be that once you have like thousands of these different parse errors and you want them to be very context specific, maybe Miet doesn't work as nicely as it does here. I don't know. I haven't used it at that scale. It might be that we want to put so much more information in each one of the parse errors that something just, I don't know, don't work very nicely. I want to take it there, see how far it goes, right? What I do think, and I can sort of see already just from doing similar things in lore, parser, where was it? Parser? Yeah, is that at some point this sort of becomes kind of annoying to work with because you have all of the actual human readable error here, right? For each one of the different errors that you could have. And Miet does an amazing job at actually using this to display very nicely things. But having the strings themselves in here is something that I'm not very fond of. I think I would like to have a table somewhere else. If anything, to be able to do some switches, depending on, I don't know, like a feature flag for the language. You have a new error, right? Because you're trying something new in the compiler and you don't want to expose the user to something yet. You just want to say, hey, this error, right, is coming from this sort of feature. Just report it here. We'll take care of that. Versus a bunch of sort of text, right, that may not actually explain how to solve this because it may be something that we cannot fix very nicely just yet, right? So we would use an internal string there, something for us to have a look at. I don't know. I just feel like hard coding the text in here doesn't doesn't feel very nice to me. In any case, right now this is what we have. So we'll say we were expecting expected. I think that's the syntax. But instead found, and we can do found question mark, right? Let's see. I am pretty sure this ain't gonna compile. That's fine. We're gonna import the token from the trait. No, why do you do that? I hate it when it does that. Okay. Cool. I wanted to run cargo build. So we say we were expecting an expression, but instead found this sort of thing. And then here we can say when I guess missing value in value declaration. When parsing module, we'll revisit this for sure. We found a value declaration or a declaration without a value. Let's see. Nope, we want to do this, right? And I guess somewhere in here we will like to include the actual string, right, where it happened. All right, let's do something. Let's collapse this first, and then we're going to look at the via diagnostics and see how we can add more information in here, so we can actually show the source code and say, here is where we found the error. We'll see how that'll work. Cool. So far, so good. Now, if we go to diagnostic, we don't have this anymore. We don't need this anymore. We may reintroduce it later on. For the time being, I'm going to remove it from main RS, diagnostic. You are gone. Excellent. Okay, so every time we find diagnostic, right? Diagnostic. And I guess that escaped. Boom. Ah, not that many places. You should just do it manually. And then the lecture. So remove that, and then boom. And I guess we have an extra parenthesis here. I wonder if we have it everywhere else. It looks like we do. Great. Line 44. And then parser. So something that was nice, right, was that we would be able to just say, grab all the diagnostics and be okay with that. So I guess right now we can, we won't be able to do this, right? We'll have to. It's kind of annoying. List all of them. Parse error. But I don't want to do that. Okay, you know what? If we get an error out of that thing, we are simply going to push it into our diagnostics, right? Why do I need that trait? Am I using? Oh. This will be parse error. I guess that's why. Yep, that seems like that. We are not using the tokens. Maybe we're not. Nope, we are, definitely. Perfect. So now we are getting some errors that I think make sense, or that I was expecting, which are related to the error string itself. Because I forget exactly how this was. What is the syntax for this thing? Logos. No, it's not logos. I am talking about this error. Where are you, this error? Docsrs, this error. There you go. Oh, just a name there. Okay, perfect. And I guess the rest was good. Cargo run, perfect. Cargo run, not build, run. Nothing. Cool, 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 cool. If I remove that, then we get a diagnostics. Okay. That seems to be as we expected it. Cargo test. Are we good? No, we're not. Parser. Got 94. We don't have diagnostics anymore. We have parse. Error. And I guess we're gonna run into trouble here. Because one thing that diagnostic did have that parse error does not have, right? Error is partial equality. But I really don't want to deal with this. I mean, I cannot use that. Am I even using IO error somewhere? Yeah, I think I am. Okay. We're gonna have to do something about that. We're gonna say could not open, could not read file. And here we're gonna say file name. And this will be a path buffer. Cool. So could not read file at, or maybe just there, say file name. Import a thing. Cool. So now we can go into the parser, and wherever we have the IO error, we no longer have that. Now we will ignore that for now and just say could not. And we say file name. And I guess we need to, we're gonna need to turn that into a path buff. Actually, let's just use a path instead of path buff. There you go. Cargo test. Box type has and what's the problem here? Okay, so this is not sized. I'm gonna go for path buff, which should be sized. Cargo build still runs. Cargo run make queue. We got that working there. And if we remove that, we run it again. Okay, sounds good to me. Sounds like we have collapsed that error just fine. Perfect, cool. So let's commit and push that. Chore, collapse, diagnostics, and parse errors. Okay, so before we actually try to do the skip ahead, we are going to display diagnostics or parsers. using Niet. We are not doing that quite yet. It rhymes. So again, Niet is this library for diagnostics, right, in Rust, and it looks amazing. And I've used it in lore before, about a year ago. So I think it's got some changes since then, like 2-3 major versions. We're gonna try to use it. We already have it installed. So if you go into like our cargo toml here, right, we already have Niet. And we are using it. It's straight diagnostic, right, to sort of work with our error type to define what are the things that will need to be reported at some point as a diagnostics. In our main file, we actually are using the Niet result, right, to deal with this. But we're not actually printing out, right, the diagnostics themselves through Niet. We're just using the debug call here to do that. So what we kind of want to do is just to sort of like getting the diagnostics, right, all together. And we're going to raise that into Niet. So when we do get the diagnostics, right, we will return a result. And on the parsing error, we're actually going to have one error that's going to be a collection of all of the diagnostics that we found. But we need to figure out how Niet works with that. So on last stream, we actually were looking into this, and we saw that there is here multiple related errors. To print them all together nicely. And this is kind of what we want to do, right? Yeah, so you can see here, it's like my error, there's a vector in the middle. So we could say diagnostics, right? And this will be vec of parser. What else do? They do related. And I guess I will have to do an error here as well. Let's see if we build this. What happens? Does it build? Cool. So that builds, but this thing does not. So what we want to do is grab all of these errors that we've been collecting through parsing, right? And since we're already saving them inside of the diagnostics vector or diagnostics function, we'll just actually return a result. Either there is no diagnostics, right? Or we have a parse error. Actually, this is not very nice. So I'll keep that for now, and we'll call this I don't know. Don't really like the way that this is looking. So I guess we could just return that, right? One parse error with everything. And just do parse error, right? But it will be convenient to do that as well. So if there's no diagnostics when you call like parser diagnostics, right? Then you actually just get nothing. It's fine. Else it will be reported immediately. I don't know. We'll see what this looks like later. We need to figure out what the main executable will look like as well. That's not something we're going to do today. Okay, so parse error, we got that. The error that we have is diagnostics, right? And we're actually going to put the whole thing there. So we save. I think we're going to have an error with the borrowing. Yes. Wait. Oh, we need around that. Yeah, there's a move there. So right now we're just gonna clone that. So at this point we know we are done, right? There's not much else to do. But let's actually check if diagnostics is empty. We'll just return an OK, right? Else we'll return an error. And we don't have clone on the errors themselves because we haven't derived that. Cool. So that's the thing. We have clone on errors. We can actually clone all these things. We might find a nicer way of doing this, right? Like a way to collect all of the vector or the an iterator of parse errors into a full-blown diagnostic struct. But right now I really just want to get something out, right, rendered out there. So I think that'll be fine. Cool. And here, if there's nothing, then nothing's gonna happen, right? But if we do have any diagnostics, then we would immediately just print out the MEAT results. Okay, so let's do that. Nothing to be done there. Perfect. If we remove the value declaration, then all right, we get that. That seems fine because this is the error from the this error library that we have specified. Hey, how's it going, Blaine? All good? So now what we're going to do is actually install the nice handler, the handler that will let us look something like this, right? I don't expect it to work out of the bat. Oh, no worries, no worries. Okay, so let's go through installing, right? So we're not really using sourcepan here. We may want to look into that. It would be interesting to see if we can thread automatically, right, the current spot in the lecture to any of the errors that we're handling. Like maybe instead of having a function to pop a token out of the lecture, we have something like with token, right? So we have to provide a closure, right, that will return a result. So if there is something wrong, then the lecture will take care of figuring out where in sort of the file this is happening and just decorate that with a source span. Because this is definitely not the way this is looking for us. But I think it has to do with the fact that we don't have a diagnostic setup. So let's have a look at some of the other examples, right? Diagnostic code. All right, let's see. It may be the case that because we don't have defined a diagnostic in any of this, right, then nothing is happening there. So we'll do code and then just mylib backcode. I think that will be fine just to see if this is what's happening. And we are expecting this one, so I'm gonna only set that one up, right? Do cargo run. No, nothing's happening there. We don't have MEAT with the fancy features. Nope. So version features fancy. Let's see. Okay, a little fancier, but along the same lines as before, we don't actually see the diagnostic of the thing that we want to report on. see a lot of examples for different things, but I don't see the thing I'm looking for. I'm looking for. That's the expression. Okay. I'm gonna go ahead and have a look at how I did this in lore again. So I am using a hook and just sort of setting the handler options here. Don't know if I need to do that. We will have a look at that. Okay, there's a bunch of struct up stuff here that I don't care about. Let's see the parser. So we have a syntax error, and this is something that okay. So I do have a parse error that is wrapping the syntax error fully. And this is the thing that defines the top level diagnostic, I guess. So what do the parser returns a parse error, but that thing is just a wrapper. Is that really how it works? Because all of the examples we had over here, right? Except this one, I think, really just define a struct. Struct again. Struct. Okay, fine. Let me try that. We'll see if that is the issue or not. So we'll do pub enum, and maybe this is why I actually had the original diagnostic as a separate data structure. Damn. We just did this, right? Just flattened out the thing. It has to be something else. Like they have an example here with an enum. We should be able to just run with that. But I guess we'll need to do this anyways to add more information, right? For the source. I don't know if it's the macros. Maybe just the behavior of the library. There's definitely something happening here that I just don't see, right? So yeah, maybe it is macros. Okay, screw it. This is the new syntax error, right? And then we're gonna do a proper parse error, and this will be the struct, right? That will define the source code as well. Just closer to what they have over here, right? So we want to be able to just gonna use diagnostic there and debug error. It's derive. So I'm gonna actually import diagnostic since we don't actually have that. And what else do we have? We have error, and this says oops. I guess we will say parse error. And when they actually invoke the diagnostic macro, they're just passing in the code param. I don't know if we need that. Do we need that? So we're gonna go q parser. Cool. So what we need here is to be able to include a syntax error, right? Inside. What they do here is that, what the hell, they don't even have the error? Source code. How do we do this before? We actually have the syntax error there. Okay. But no, to have multiple related diagnostics, we actually need to have parse error because they may be in different files or different sections of the same file. So we'll do just that. Derive that, run again. It'll fail because we need clone. We're trying to clone that at some point. Perfect. I mean, I know that it's all right here. Me saying perfect doesn't make it go away, but it's kind of what we wanted, to split these two things again. But instead of being two enums, now we have an enum of things that can go wrong, and then a struct around it that can help us define more information, such as the source code for later on, right? And perhaps even the what do you call this? The wiggly line below the thing that is wrong. Does that have a name? They're calling it snip here, and an error span. All right. However, let's fix these errors and move on. So we want to grab diagnostic everywhere, right? So at some point, no, actually not even diagnostics, just parse error. Fine. I'll just do it by hand. Parse tree. Can't be that hard. So this will be syntax error, right? And then in here, or actually, no, this will be error. And here we'll have syntax error, and it will be that. Yes, like that. So we're gonna import from the crate. Perfect. And what I want to copy is that, because I will use it here, right? And then I will use it somewhere else. Here. And of course I need to close a few braces here and there, but no biggie. It'll be fine. Parser error, and then this will be error, and then we got syntax error, diagnostics, and we're gonna put a brace there. Boom. Excellent. And now in the lecture, we'll have end of file and same ordeal. This will be error and syntax error. And the same happens here, right? So error, syntax, error, and then a new brace. Cool, just need to import that. Import. Cool. Now in the parser, I guess somewhere up here, we will need to do the exact same thing. And later on, we can make this nicer with a little function, right? I'm sorry, what? Oh, this field in error is private. There you go. Don't complain, run. Excellent. We're starting to get something. Parse error, found many errors. That is not what we wanted. We want each one of the errors to be displayed. And this is bothering me. Okay. Can't really make sense of this right now. We got a parser, we got a source. I will set up the meet hook at the beginning. But I'm wondering, like, do we need to do this manually? Because we did it before for lower, and we just pass in a box, right? And we return the options here. But I would kind of like to use the default one. I will need to pass an argument there. This is just not the way it's being used here, you know? So in the example they have, they just have a struct for an error, right? And say this error will be a diagnostic, and they derived something for the diagnostic, and we get the URL, the help, right? And then in the function that fails, they're using the meet result, which should be fine. That's the thing we're using here as well, right? And then they call it. They just call it. And the output is that. Okay, the default reporter should be set then, so we don't need to call this. So what is missing here for us to actually see the errors that we have? Because related is not cutting it. I wonder if the problem is that we just have a single top level error here, diagnostics, but in reality we should say related at that level. Yeah, I know what you're gonna say, Blaine. It's like, but errors. No, we can't do that. It's gonna be horrible. Whoa, Fakey Nichols. Thank you so much for the subscription, man. Have a good one. Sure, you would never. But you're right. Like, if this was not a macro-based library, if I was actually setting everything out myself, then at least I would know what the hell is happening, right? When I do build or run, it'd be like, oh, I am not dealing with this value, right? Instead of the macro magic not doing its magic because I am sort of holding the wand wrong or whatever. So in that sense, I still prefer non-macro code, but I kind of like the macros sometimes. The tension is real, folks. It is real. Would I want to maintain this with all these macros? I don't know. Hello, hexadecimal 3. Good to see you. How's it going? Right, you know what? Let's see. Cargo expand is probably a separate thing, right? Yeah, play around with cargo expand and see what the hell is happening here. I am running on the default one, stable. I can move to unstable as well. I'm not really looking to ship this anytime soon, right? Oh, it did? Damn. Did you get any audio? I'm getting an unstable label on the bitrate as well. 2900 kbps. Yeah, it's frozen for me as well. But that sucks. Let me do something. I'll try it because I'm also streaming to YouTube. So I'll just kill that, see what happens. Hopefully, it won't stop this stream as well. 3, 2, 1. Stopping. The YouTube one. Still stopping. It can't seem to stop stopping. But maybe in a second that will make the connection stable. I mean, why the hell does one pay for a massive bandwidth sort of cable over here if this ain't gonna work? Cool. All right, so I'm done streaming to YouTube. It's only streaming up here. The bitrate should be back at 4,000, something like that. So maybe my connection will be stable. Will appear stable any second now. I will refresh. Back. I mean, I refreshed the page. I probably didn't leave. Is that better? Let's do. How do we use cargo expand? So the options. Excellent. We need the nightly toolchain. Why? Okay. So technical issues seem to be out of the way. You know what I'm gonna try? I'm gonna try actually getting one of those errors out, just to make sure that that works. So whenever I do parser here, right, instead of getting all the diagnostics, we're just gonna get the first one. Cool beans. Cool beans. Thanks for helping diagnose that. So instead of doing this, we're gonna get the first one of the elements. Probably no nth, but at. Ba-da-ba-ba-bum. Contains. I guess we're gonna have to do indexing directly into that. What? This should be fine. Why is diagnostics a parse error? Oh, it is. Duh. Okay. Cool, so that's that. And if I do cargo run, okay, so this part works fine. We're parsing a module, right? We found a declaration without a value. That's great. Still not exactly what we want, because we want to be able to read all of the errors at once rather than one by one. Like, I don't want to go, to a file and fix one line and then run the compiler again and do the same thing, right? I want to run the compiler and get as many errors as I can that the compiler knows are errors. Then I can just fix those and then run it again. It should still be possible to do the one error at a time sort of flow, but at this point, just show me everything that's wrong with this file, which is what you would expect out of a language. We're running cargo build here, and we get a bunch of errors or warnings sometimes for the same file, and that's fine, right? Okay, so parse error when parsing module found declaration with a value. Cool. And the alternative here is to just wrap that in diagnostics, right? And say parse error, this is the whole thing. So I think I know what the problem is. Here, I'm gonna wanna say a 0 and just do the debug version of whatever this is. I think. No, probably not that. Let's see. No, definitely not what we wanted. How the hell does one go ahead and do that? Related. Do I need to remove the error for it and just say related? So Miet takes care of that. No. Error display attribute. But if I use error, then it's going to use this thing. It's going to ignore the rest. But I don't want it to do that. So what would happen if parse error actually only has... Right, so let's say parse error actually is one error, right? And that's fine. And we also have top level diagnostics, right? Struct, which is essentially this, right? A parse error. And in here we actually have related. So errors, and this will be a vector of parse error. Why would I do this? I think maybe a problem we're having is that why would I do this? When I use a source for a single error, and that error has a lot of related diagnostics inside, that doesn't seem to be working. I don't know if that's a bug or if that's just how it's intended to work. We could start reading some of the Miet source code and have a look at that. But at least what they say you need to do here, right, is have a struct that's your I guess this is how they want to do it there, right? Your error, and then inside there you have inner errors, which are kind of like our parse errors on the left here. So if I did that, do they have yes, multiple errors? If I did that, then parser rs here wouldn't actually have that, but it will be diagnostic. What's it called? Diagnostics. And then we have errors, and this will just be all the diagnostics, right? Because those already are errors. Okay, I hear you. I'm not impressed yet. I think we might need to put some more things in the file, right? Okay, this seems to be doing something. Yeah, my guess is that maybe we will not do this. Maybe we'll just have our own diagnostic or syntax error type, right? And we'll just collect all of those, and eventually, because we know where they are, right, we will use something lower level than Miet, right, to actually render the source, right, and render the little bits that we want, and the squiggly lines and everything. I mean, I imagine that a lot of the things that you get for free when using the macro, right, are things you can actually call directly. Okay. For the time being, I think this will be okay. We got a couple of errors, right? We would want this thing to be just 2 errors rather than all of the errors that it is, right? One saying, hey, we got this declaration here, you should have used equals instead of question mark. And then this one is like, yeah, this one's fine. When parsing a module, found a declaration without a value, right? Okay. Let's bring in some context from the lecture and see what we can do there. How did we do this before? So in lore, I know I keep bringing this up, but it's useful to have used the library before. Have something that more or less works. In lore before, we had a parser error, right? And this thing is going to use a named source. Let's see where we're building this. Oh, okay, that makes sense. So whenever we actually find an error, we're just going into the lecture and getting the current span. And the span will give us exactly where we are, right? And then we turn that into something that Miet knows how to work with. So we got a parse structure here. It's very close to our parse module, right? And for every error that you get there, so I guess the difference is that we are actually collecting all of these errors rather than just immediately failing. So we will have to do this inside of our parse loop, right? But we're just going into the lecture and saying, give me a span. Okay, so we can do that. Span. And I guess you always get a span. Range, size. Right, cool. So self-lecture.span. Nope. And we're going to import that. Cool. So in our parse loop, right? If we get an error, we will want to add more information to the error. So here we'll get span. And this will be lecture.span, right? In fact, since we know right now that we're going to get a span that is going to be relative rather than absolute in file, so we can get like span start and span end, right? and we can do return span start and then span end minus span start. Which I think should be fine. Oh, right. How do we do that before? Oh, it's just range. Nope. Range dot. Cool. We are returning a tuple. I guess we also want to turn that tuple back into a range. Into, what do we use here? We use the source span. Okay. Oh, but this is a Miet thing. I don't like this. I don't like that Miet goes into our lecture like that. Okay. So we'll have that. That'll be fine. So this would be a Miet source span, right? Like that. We don't need that though. And we want to be able to do parse error. And here we will do a span. And we actually want to put in the span. But we also want to put in other things. We will need the source file. I wonder how much of the source we actually need. Before... Oh, we actually passed the entire file. Okay. Yikes. And what does this need? Name source. So what's called? It's called source. And this will be like named source. And we actually have a constructor for this. So new. And in here, since we are inside of the parser, we know the name of the file. No, we don't. So we're gonna save that file name. It's gonna be puff puff because we don't want to have a reference to that. If you build this from a string, then you don't have a file name, which is fine. Import. This is the sort of thing that comes back to haunt you. You were like, yeah, it's fine. But it wasn't. So self file name, I'm gonna give you that, and we're gonna do source.clone. What else are we missing here? We got a parser, we got the span, the error itself, where does that come from? Here, right? So we want to do parse error, we want to pattern match in the error, right? And we want to ignore the rest. And this is what we're gonna do. We're gonna sort of wrap it like that. Cool, so that should actually build soon. Source and span, we don't yet have those things. We need to add them to our error. That's fine. We're gonna go here. I'm gonna say pub span, right? And this is going to be a source span. And then we're gonna do pub source, and this is gonna be a name source. And I actually think that we need to tell Miet with annotations where exactly to put this stuff, right? Code. Source code. I guess we have an example somewhere here that had a snips. With no text. Import, save, Oh my god, we don't have that name source we can compare. What do we need the clone for? The no, clone doesn't work. Are you kidding me? How am I supposed to do any of these things? Error. No, it's called error. Error. Sure, we could do that. Replaced by the pond name. We're missing span and source everywhere. Everywhere. Oh my goodness. But we don't have these things. I mean, the lecture has some of it, but we don't actually want to return all of that. So maybe instead of returning parse errors everywhere, right? We're just gonna return syntax errors, and we're gonna let the level above say, well, you failed, so we're gonna decorate you with stuff. Which is another reason I'm not liking much this pattern of using a trait for parsing based on like the different parts of the AST. Because we could have access to the entire sort of parser, but we don't. We just get the lecture, right? Get a mutable pointer reference to the lecture. Which is not doing us any favors right now. Getting in the way. Okay. So, parser error, we're going to change that to be a syntax error everywhere. Parser error, parse error, syntax error. There you go. That's the stuff. So now we can just return the syntax error, which is also a simpler piece of data. It doesn't have all this wrapping, right? Boom, there you go. And then you can get rid of that. Save. I think for the most part, this module should be good. Except that, oh no, lecture.next doesn't like this. Why would you do this? Damn it. Syntax error. Ay. Syntax error. Yes, I am not digging this right now. I think we have made a bad decision. I just don't know which one yet. But something smells. Like maybe the lecture itself knows too much and shouldn't be returning an error here. Maybe we should keep the lecture much dumber and just return optional tokens, right? Like, why do we need to modify these parts? Okay. Going back into the parse tree. Now we need to modify the trait. Syntax error. Cool. So parser line 61. We won't actually get a parser error. We get a syntax error here, right? So this will just be an error there. And at this point, we can wrap it into a parse error and just be good. And actually, yeah, I think that should be fine. Okay, we need to import this thing. Import. Well, actually, just gonna put that up there. What don't you like? File name. You don't like that this is that. Okay. I think we'll need to turn it into a string, and that's a whole dance that we actually have done already here. So I'm just gonna grab this thing. and be like, all right, boom, there you go. Cool. We don't really have the ability to clone things anymore in the diagnostics because some of these things cannot be cloned. So for the time being, I am actually gonna make this consume the diagnostics like that. Cool. Index error, not too big of a deal. Where are you? There you go. There. What else? Unused import. That's also fine. Get rid of that. Then the parser doesn't care about tokens anymore. Don't you though? Yeah, you do. This is misleading. Cool. So line 23. Here we'll just return could not read file. Because the parser error actually returns a syntax error. No, we can't do that. Right, this is not really a parsing error. This is a separate kind of error. I am not liking how this is turning out. The whole error handling and trying to collect the diagnostics to just pump them out all at once. I think this is fine. This wrapping is needed. I get that, right? But like, could not read a file. That's not really a syntax error. It's a different kind of error. Oh, man, I miss OCaml polyvariant so much. I'm gonna cry. Okay. We don't have a file here, so if you cannot read the file, then there is no file name, there's no source, right? So we cannot really return as one of this. Say, no, there's no file there. You know what? I'm just gonna unwrap right now. We will deal with that later. Yay! Finally, okay. So now we actually get to see the error. We have file name here. The error string, right? We have the actual error here, and we have a little squiggly line saying, pointing at the thing that's wrong. This is not like great yet, right? But the library is giving us the tools to actually build errors that would be good. Yeah, you see here. So I guess if we had some labels to that, then we'll be able to say, oh, this is the symbol that is missing or wrong. Now the question is, how would we actually grab that label, right, and give it a name, right, or rather change the text of that label dynamically? Because if this label was said something like, here's the error, right, then when we build this thing and run it, It'll be like, oh, here's the error. But that's not what I wanted to say, right? I want it to be specific to this particular error, right? So they have some examples here. This bit here. Yeah, so I guess this library is expecting us to define each one of these structs, right? To have individual source spans. So, just as an example, right? We'll have a struct here that will be, for example, right? And what's the name of this error? Missing, you know, value in value declaration, right? And here we would have a span or a label, and it will say we expected value right here, right? So then you will say here's a span, and there will be like source span or whatever. Oops, sorry, missing a bracket. So that way, when you create one of these errors, you have to say this is exactly the span, right, in the source file in which this error has happened. So you can actually have the label that you want there, pointing at, I guess, this spot here that we cannot really see, right? So then that way, different errors like this, right, expected expression and so on, will have their own span, and that span will have a value or a label value that will be used by the library to render that. Okay, I get that. I see how that works, I think. Let's actually have a look at source code and see if that's how they would do it. So I imagine that they have some examples, right? Maybe tests. Let's search for label. Let's see what we find. Right. I wonder if it'll be easy to just use the library instead of deriving things. Irish. Chain. Handlers. Nope. Name source. Is that where the span is? Okay, so the source span comes from the lib here. Really? error. Chain. There you go. It's in protocol. So what's in here? Core of the MIA protocol, series of types and traits you can implement to get access to MIA8s and related libraries, full reporting and such features. Excellent. Cool. So we have a source span, and this is just a struct of set length. I guess at the end of the day, we still will want to have separate types for different kind of errors. Like if this was a camel, we would be just using maybe inline records, right? To define all of this information. But because we're using so many macros, we could inline this error anyways, right? In the enum. Right, you'd be like that. It'd be fine. You wouldn't say pub, but yeah. So every one of the errors will have all of the information they need, like a span, name source. I don't know. I don't know why I'm like bothered by the name source. Why doesn't this just have a reference to the source code instead of having to own it? Why does it have to be static, right? I get that the program is ending, right? But if you're parsing a bunch of files, hundreds or thousands or something like that, maybe it doesn't matter. Maybe it's just like, okay, at that point, we'll just duplicate the contents of the file as many times as we need to. I feel I'm misreading something here. Named source. So this is a box, just a pointer to, right? Something that implements source code and is static. And source code will come from protocol. Do they have any implementations of source code? Do not know. Okay, well, but if that's what it takes, then that's what it takes. That also means the approach we were taking before doesn't quite make sense. We won't need to have two layers of this, right? One that defines the error and the other that wraps it with metadata, but where it's happening, we just say the error itself is self-contained, right? So if you have a span here, right, in a missing value, in value declaration, syntax error, just then you would actually have a span, and that points to the place where you wanted the value to be. And then you will also have the name source, which will be the actual source code that you're sort of expecting to point into, and any other metadata that you want, I guess, here. That doesn't make that much sense though, because then you would have to include like a source error inside. separate from this thing. Like there will be a missing value declaration error struct that defines how you're going to be rendering this one in particular. Or would you say, you know, just that? And this string sort of takes care of the human readable version of the error. Like, let's say if I try to build that, it's probably gonna fail just fine, because we no longer have the possibility of cloning or doing partial equality. So we have to go into the parse string and say, well, when this happens, actually, right, you will want to do a bunch of stuff. Not just that, but also get the file and the named source, which I'm going to steal from the code we just wrote here, right? Span and source. But we don't have access to the file name nor the source because we are inside of the trait implementation. Okay. So maybe it's time to get rid of that. Maybe that'll be fine. Okay. I need a second. I will be right back. And we're back. Thank you. Right. Missing value declaration. So I appreciate the work that Miet does, right, in standardizing how you're going to be reporting these errors, because I will want to have a span, right, and I will want to have the current source that I am operating on, right, so I can eventually display nice errors, nice diagnostics. I'm just thinking, what would the pattern look like that would help me define individual parsers while maintaining sort of the structure of that diagnostic, right, with span and source and so on, without having to redo that work over and over and over again. Because I really don't want to say, hey, here's a syntax error, right? And I had to get all of this stuff from the lecture, right, and from the parser itself to put together a syntax error, right? Because at that point in time, the lecturer should have enough information to say, oh, something went wrong, this is where it went wrong. Or at least the parser should have that, right? But then I would have to sort of duplicate part of the error information, because I would need a partial error, right, that doesn't include that information, that the parser can pattern match on and decorate with that information. So, for example, here I would just say, all right, what I care about is that there's a missing value in value declaration. This is a parsing error. This is really what's happening, right? That's what I know. This is what I care about. A level above here, right? And I'll just duplicate this so I can butcher it, right? We want to be able to say, okay, here's this specific error, right? Grab all this information and build a new error that is going to be pretty much the same thing, missing value in value declaration, right? With a span and a source, right? Because that's the error that at the end of the day we want to pass to MEAT. So this is the error that would actually have the information about how to display itself to a user. But of course I don't want to do that, because then I need to have two of every error. And that sounds like a waste of energy. Of course, I could try to be more generic here as well in some ways. Like, for example, maybe the error in parse error, right? It's not directly the error I am trying to add, but rather is anything that sort of derives from or actually implements the error trait, right? Would that work? But the problem there is that then I don't have information about what span I am on, right? So I cannot set the right label. See what I mean? Like, if I had some way of saying I am going to declare what the error is, right? And what the relevant spans are, right? But defer that to a single data structure where the source span itself includes, right? Plus whatever text it has, whatever label it has. Then it would be easier, because I wouldn't need to think much about, actually, if this was just like a vector of, that would be brilliant, I think. Because then I could just say, okay, whatever you are actually trying to report on, right? Assuming that it's all on the same source file, then you can just tell me, hey, these are all the spans with all the text they need. So you can put together that data structure based on the things you know when you're building that parse error, right? Which I guess would have to come from the error itself. How do we tie these two things together? I don't know. Do you folks have any thoughts? Any inputs? Any ideas? Maybe Blaine, if you have a thought on how this is being handled in grain right now. No. Okay. In the meantime, we're actually just gonna do the boring thing. We're not gonna have a parse error anymore. We're just gonna have syntax errors. Actually, this will be a parse error. And our top level diagnostics is just gonna be a collection of those things. Every invalid parser state. Right, I remember that Manir has a way of defining the error messages as separate file that sort of gets linked into the executable at the end, right? Something like that. But I didn't know you folks were using Manir. And you were throwing shade on me for using a macro-based system. Shame on you, man. I mean, I guess we could just define traits here, right? If I had a trait for a parse error, then I could define all of this separately or wherever I want as structs and as. Damn, 300 parse errors. I forget, but this I guess Manir has an incremental parser, right? Like I remember it generating an incremental parser that I never got to use, and I guess there it's doing some of the things that we're trying to do, right? Collecting all these errors, making sure all the information for where they happen is preserved. What do you mean by an arrow hack? Like to use the arrow for functions? Oh, or you mean the pipe, the arrow pipe? Yep. Yep. Okay. No! What do you do? You. Oh my god. Yeah. I'll take care of that bot. You should not be banned here, man. So So where is it? Hype Fury, Carbon, Nightbot. Regulars. I guess if I put you as a regular here, they're not gonna fade it. Submit. You may not get banned now. Do I try posting that again? Oh, never mind. I found it on here, so yeah. I made you a regular of the show, but it's not working, so I need to figure out how the hell Nightbot works. Sorry about that. Alright, so let's have a look at this lecture hack. The lecture hack is a common solution to the problems in parsing ANSI C due to the reference grammar being context sensitive. In C, classifying a sequence of characters as a variable name or a type name requires contextual information of the phrase structure, which prevents one from having a context-free lecture. Problem is that the following code, the lexical class of A, cannot be determined without further context information. That's correct. I guess this will be a type here, like casting the pointer or dereferencing B and then casting that. No, multiplication of two variables, in which case A is variable written unambiguously. No, okay, so this is that case. Alternatively, it could be casting the dereference value of B to the type A. Okay, so that's what I thought this was. But wouldn't they be like different? Yeah, yeah, exactly. So because a near is LR1, it only gives you the next token. But is there a token specifically for tuples here? Like, is there a difference between that parenthesis and the other one? Let's find out. Declarative lecture. Fun token. Oh, we just have left parentheses and right parentheses. Right, line 52. So I guess this is triggering token function is really the one that's deciding, right, whether we are going to do this. Right. Equal greater colon. So if we begin with a left parenthesis or a left brace, right? And then we try to balance the closing parenthesis or brace, but fail. Wait. Try with. No, this will like blow up the stack, right? Like this will just race from here. So if it is balanced, then we are going to do. Oh, you're back. Welcome back. So we'll try to get a token, and if we do get a token after that, but I guess at this point, right, we've already parsed a sort of balanced left and right braces, right? And we're going to check if there is a triggering token, which should be either the colon for, oh, okay. If we find a colon or an equal greater, then we want to inject the ES fun. And only then we actually, no, we're using this in both cases, right? I guess in one we fail and in the other we don't, but we're going to use the balance parentheses, and after that we're just going to put the token. So that thing, what would it look like? Ah, is this explanation? Dot 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 with a closing brace indicates that we're definitely not in an ES6 font. Imagine the following. Don't know. I would have to sit down with this and actually see some examples in action to make sense of it. For the time being, I'm just going to go ahead and actually put more information into these errors that we have here, because we will essentially need a span and a source for every one of these errors. And I want to believe I'm doing something wrong, but it doesn't look like so, especially if we're going to have different labels on the spans. Even then, like, you have something like unexpected symbol found, right? And we want to be able to use some, like, the name of the symbol in the label. You can't do that. You have to actually, what am I going to define one of these for every symbol? That doesn't make sense. So maybe, okay, let's start by just making this work with one of them, right? Having the labels inside, the values inside. Cool. So parser 9, we can't really have this information anymore. We will need to be able to pass into the parser itself the file name and the named source, and I think that's going to be slow if we want to pass a named source. So maybe it's time we start moving some of the logic in here so we have access to more things. Okay, fine. We tried. We're gonna do parse module item, right? Self.parse module item. And we're gonna pass in the lecture like that. I think that'll be fine. I guess it would be even better to not pass anything, because then we can create the lecture the moment we create the actual thing. We say from file, we get the source, and we just say that there. Okay, one thing at a time. I'll keep the lecture around. And we'll deal with that later. So pub function, actually just function, parse module item, and we'll get a mutable version of ourselves, and we also will get a lecture, right? And this will have the same signature. The same signature we had before. Except that we're just gonna grab this stuff. And we're gonna say parse a value declaration. Self. Create the function. Perfect. No. Just pass that there. Cool. So it's gonna get nasty before it gets nice again. And this is gonna be module item. And this is gonna be value declaration. Cool, save, done. So this is gonna be parse ID, right? And this is gonna be parse expression. So generate that, self dot mute. Cool. Save. Token, import. Cool. Generate this thing, generate that thing, generate all things. Cool. So now we have that. Amazing. This will be for expressions, so we're just gonna go there. Say parse expression. that. And now we want to get it for the ID. So let's get that, and that comes in here, and result ID, syntax error, perfect. So syntax error, we want to what? Unwrap? No. What you doing this for? Can I find syntax error in the scope? What do you mean? Can find? No, why you do that? I don't like it when you do that. Just there you go. Okay, so this can go away. Save. Syntax error. I guess now we'll be able to import that from somewhere. Oh, right. It's not called syntax error anymore. It's called parse error again. Cool. Save. Better. And now this thing is missing a couple of things, which is fine. Because now we actually have access to the lecture and the span and everything. So we can say, if we do have an error, when we do that, we will actually get the span and source, right? And this we can get from, I guess the lecture will need some of that. The lecture will give us the span. And the source we will actually need to get from the self. So name source, we can do that. So we can do span source. Cool. So this can go away because we don't need that. This stuff's not being used and we're just pushing in the error. Build. Almost there. We no longer have a trait called parse. We no longer have syntax error. Say, there you go. You can remove that. We can remove that. We can remove this over here. And we can remove this over here. Ah, great. We can remove all the stuff. Nice. Cool. So lecture, you also don't have syntax errors anymore. Build. Line 42, you don't have syntax error, you only have parse errors. Perfect. Say build, I'm gonna have to import this. Excellent. The last thing we need to do is to actually get the parser to give us a name source, right? And we can do self there, and we can just return a name source. And if we look at the place where we were defining a name source before, where was that? We removed it, didn't we? Yes, geniuses. Whatever, we'll do fine. We wanted to have a file name. Yes, file name. And then the actual source. So this will just be a call to new. And the first argument is self.file name and to string. And I think we just do the unwrap in there. Unwrap to string, yeah. And the second one is actually the source, which I think we need to clone as well. I forget. Yeah. Clone there. Cool. Okay, this I don't like because now I have two borrows and because I'm borrowing from the lecture. The lecture is borrowing the source, and then when I try to parse the individual things, right, I'm getting a mutable borrow on self, which maybe I don't need actually. I may need, but maybe I don't need right now. Okay, look at that. It is working. Excellent. We can do that here. I don't need the rest of the thing. Perfect. Cool. So we have multiple errors. I don't quite like that they're prefixed with error like that all the time. I think this is never constructed anymore. No, I need that. Fine. Just build, run, do your thing. Okay. So this means that now that we moved all the parsing code to the parser, we have access to the lecture at any point in time, and we also have access to the parser itself. So we can get the name source if we need to, right? To, in conjunction with the lecture, put together the actual parsing error that will tell us exactly where something went wrong, right? So that we can report it nicely. Well, that was a journey. And we haven't done the skipping ahead yet. But I think we have enough now to start defining more structures of the language, right? At least at the parse level, more expressions such as function definitions like lambdas, right? And also function calls and a few other things, right? And maybe like an if expression, for example, right? And then we can say, all right, we have that very basic version of that. Let's move on to the next phase and start doing a little bit of static analysis and that sort. I think that'll be fun. So we wouldn't actually spend a lot of time doing like entire lexing and then entire parsing and so on, but just define like a super tiny language, right? Throughout all these phases. All the way till, code generation at the very end. And I thought something fun to consider, right, was that somebody here said, Camille was saying it should have the portability of JavaScript, right? And maybe that means that it compiles to WASM, right? And I thought that's cool. We can probably consider that. I don't know what that would mean for all the IDE tooling and stuff like that, right? But if we're gonna need the scalability of Erlang, right, and also to be able to have the portability of JavaScript, maybe we'll get to play around a little bit with Lamb. Not that we will actually use Lamb. I think we can do better by just defining a much smaller thing that we need. But Lamb is sort of an abandoned attempt, right, at defining this lightweight universal virtual machine for sort of actors, right? And it was fun. Actually, it runs and does stuff. It turns beam files from Erlang, right, into some functions of its own bytecode, and then packs that with a runtime, and then you get sort of something that can run locally, natively, or on WASM. So since we want to have the ability to do processes, right? So Erlang style concurrency, then maybe we'll get to define a tiny virtual machine. Yeah. I've looked at Lunatic at some point around the time I was working with on Lamb, right? Playing around with Lamb. Actually, a little after I stopped. And I've had a couple of chats where I want to say Bernard. I forget. Bertrand. I haven't spoken to him in a while. Colobara. I think it was his thing, his handle. I'm super happy with the stuff that they've been doing. It looks amazing, right? And I'm super happy that they've gotten funding to take that to the next level and to actually keep building it. I mean, I think just as someone else was pointing out, like, oh, if you look into these languages, maybe you'll find what you're looking for. I'm like, that's fine, but that's not why we're doing the live stream. If I was just searching for a language to use, then I wouldn't be sort of live streaming how I. Oh, amazing! Green rounds on it. Cool. Yeah. But yeah, I wouldn't be live streaming how to, or my quest for searching the language is more of, can we build this, and just try to do that end to end, right? From lecture to runtime. I think that'll be fun. Yes. So as we stand, let's see if the tests have failed somewhere. Yep, we have. uh, well, I think we could very well start looking a little bit into how you're doing things, right? I know that you're reusing the OCaml type checker for some things, but then after that, I understand that you also run on Wasm, right? So I'd love to poke at Green and see um, how you went ahead and did that. So it'd be amazing to have you on stream, right? At least on the chat, right? To point at things and be like, no, look at this, look at that. I think it'll be super useful when we get to a point. For the time being, I think the next step from here, after I fix these errors, which we'll do in just a second, would be to go into the macro system, right? And say, can we actually define a little macro expander, right? So we go from lecture to parser to the whole macro system, right? And once the macro expansion has completed, then we can go into the type safety bits, right? Figuring out how to bring some type safety into this language, right? And once we have that, then we will have a language that should be expressive enough for you to build your own abstractions, right? But also safe enough so that whatever passes those two stages, right, should be known to be fine or safe under some definition of safety that very likely will be very basic at the beginning, right? And then maybe we can expand as we grow the type system, right? And then, right, we go into the whole, hey, let's actually make this thing run somewhere. But I don't know, maybe we just go from here, once it sort of has the primitives, into running it. And then we sort of constrain the language with the type system and so on a little bit. Anyways, it's a lot of fun. I'm happy to have you around here as well, Blaine. I think it'll be a lot of fun to have you around for further experiments. Okay, so I'll just fix these errors because it's getting late and I want to commit something that's running and then go to bed. So, problem is that the parser tests in line 160 are comparing the vector and we cannot do that anymore. I don't know how long we haven't been able to do this. I think this test in particular, maybe we don't need to have. Okay, remove that particular one. But I kind of want to have it. Let's see what happens if we grab this thing and we also say partial EQ, right? We derive partial equality. My guess is that it's going to fail. Yeah, we don't have partial equality for name sources. That sucks. So we can maybe, just maybe, right, do this. Get each one of those things. Since we know there's two, right? No, what am I doing? It's the same thing. Matches. Maybe we can say assert, and then it will be like matches. Yeah, so this ain't gonna work, right? Because here I'm expected to just have like a pattern, something like that. That'll pass. But then the only thing I'm really testing on is that it is this structure, right? So maybe I need to actually just put the name here. ID val. And then I can assert that the ID, right, is name, and that the value is qlang. These values are not found. Parser diagnostics 1 dot expected be a token ID. Now that's not going to work because I need to pattern match on the actual kind. I am tired. Can tell because I'm missing all these tiny things here and there. If I borrow that. Wait, why would that be a problem? So assert equals, right? ID here, token ID name dot to string. Isn't match actually doing matching? Maybe it's not doing unification, it's just pattern matching on that. Alternatively, I guess I could just do this. I'm gonna do a let. Right, so then we get access to both those things. And then we can say ID. Yeah, this will just be a name. And then value is gonna be qlang. Well, gracias por venir igual. Se agradece. And we're gonna borrow this over here. What? Pattern in a file. No, but I know I'm explicitly trying to break here if this doesn't work. How is one supposed to do this? I have a type that I cannot derive partial equality for, right? Is the right thing to do here to actually manually derive partial equality? Because if I do that, then this will work. Like the only thing I need to do is skip the check, right? The equality check, right, on the name source. So I could come here to this error and be like implement, right? Partial EQ for parser error. Oof. Thank you. Yeah, this is kind of what I wanted you to do. Expected expression. But what I don't want to do is to source. I'm not going to check the sources. Or will I? File name. Inner, Dean source code. I don't want that. I want the name of the file. Where are you? Okay, fine. If you get two of this, then I don't care. You're gonna compare the spans. Cool. All right. So that did the trick. We have a custom partial equality for this, which is completely generated. Yeah. So cargo run still runs correctly. We get the errors. And if everything looks good, then everything looks good. Excellent. Cool. We did manage to do that, so I'm gonna, sorry, I meant displaying parse errors using Miet. We're gonna put that here, marks across. I think our next steps, right, will be to define the smallest Turing complete language, right? Or I guess the smallest set of constructs that make QLang Turing complete, because right now we don't have most of those things. And then we go straight into the micro expander. So we might also want to have a look at this. I think probably we will. So I'll just put that there, since we missed that. Okay. Here we are, formatting all the code. Everything seems to be building, be testing. So commit. I'm gonna do a feature here. Better error reporting using Miet. And that will be that. And we'll push. And check that it's there. Amazing. Okay. So here we are. This is where we are going to stop. 3 hours and 33 minutes. I am exhausted. It's been a lot of fun, folks. Thank you so much for hanging out here, for the pointers, for the comments, for the feedback, for the troubleshooting. I hope you had a fun time as well. And yeah, we'll continue learning and building QLang as we go along, right? I think I'll try to post something somewhere about like what the next steps will be better. But it's likely that this will be on a stream by stream basis. So we finish this one, we figure out what the next, and the next one will pick up and so on. Yeah, so thanks a lot for the time and have a good night. Cheers.